Hello, my name is Ryan Beam, and I'm a student at the University of Kentucky studying economics and statistics. In this series, I just kind of want to explore how data is applied in the real world and how the field is evolving and continuing to grow. Today, I'm joined by Connie Brendle, Principal Data Scientist at Oracle. Connie, thank you so much for being here.
Sure, happy to be here.
Yeah, so just to kind of start our conversation off, the first rabbit hole I wanted to dive down was just your overall career and your progression. So I know you started in mathematics and operations before moving into data scientist and eventually becoming a principal data scientist at Oracle. So I just kind of want to know, how has your career progressed or some of the major pivots or decisions you had to make along the way, and how did you make those decisions?
Yeah, well, it's actually funny. I wanted to be a doctor. And then in college, I was told if you majored in something like biology, it was very hard to get into med school. So I chose biomedical math because it was pre-med as well as math. And then so I went through school thinking I was going to be a doctor. I had an internship at a doctor's office my senior year. And then after I had a job at the doctor's office after I finished school. And I just started to have questions at the doctor's office. And I had data, so I just started to dig into it. Like, how long are appointments taking? Are there some doctors that are running longer than others? Just questions like that. And I would just pull the data and answer them. And so I got really interested in that side. And then I had some friends who said, "Oh, we have this company, Data Logics. It's really cool. You have a math degree. Come work with us." And so I just went to Data Logics and started working there. And I was a data analyst. So same thing. I looked at data, answered questions. We got bought by Oracle, and so I went to operations first in Oracle. And that was good. It was a good experience. It's always important to learn how to do dashboards and visualizations and things like that. And then I wanted to look at different data and answer different questions. So I moved to data science, which is kind of a deeper dig into data. It is more about, the statistical approach and how can we prove these answers with the data we have and everything. So I moved to data science. So that was kind of my journey.
Yeah, that's really interesting. Thank you for sharing, and it's cool to see how you were able to pivot, and how that's just really interesting. I really appreciate your perspective on that. So, kind of moving off that, within once you got to Oracle and your progression, I know you started you went into data scientist, as you said, and then senior, and then principal. Kind of like across those roles, like how did your day-to-day work change? How did your responsibilities change as you moved up the ladder at Oracle?
So it starts off as a regular data scientist, more your manager says, we have this question. Let's do these pieces to solve this question. And so I sat there, at the computer and I did programming work and I said, okay, you asked me these questions. I pulled data and here's the answer to these questions. And this is what I think it says about them. Then as you're a senior, just generally, when you're walking up the ladder like that, just in any company, you kind of naturally get the technical knowledge, right? Because you're doing more and more coding, you're doing it a lot, so you kind of build that. So to go from a regular data scientist to a senior, it's more about, so here is the high level, the big picture project. And then it's more about here's how I want to get this big project done. And here are the important things I think we should look into. And then here are the other people I can talk to externally from my team. So more around communication. And then as I got to principal data scientist, I feel like that's a little harder for managers to manage because the principal data scientists so the senior data scientists would take what their managers brought to them and solve it. Principal is more, they bring stuff to their managers and they say, here's the problem I think we should solve. And I want to do it like this. And let's do it this way. And I'm bringing this team in to help us. So it's more about bringing stuff to our managers.
Okay, that's interesting. I mean, I know I have seen like, the positions of principal and things like that in different organizations. So I wasn't 100% sure on, that's an interesting insight. I had never thought about, bringing the problem to the managers in that way. So thank you for sharing that. So kind of shifting gears just a little bit. Something you've emphasized that I've seen in your profiles is end-to-end ownership, from the research and statistical methodology to production pipelines and things like that. So my question is, what part of that life cycle do you think maybe yourself in early career or just early career data scientists in general, underestimate the most or misunderstand? And what's your favorite part of that cycle?
Sure. So I have been around a lot of data scientists that are coming out of school and everything, and they come to me and they say, "Oh, I want to do a deep learning model or I want to do a neural net," which that's a really fun part. And in school, you get to do that and everything. But you have to start a project with things like, how do we get data? Where is the data that we want? Like, how much data can we get? Is the data clean? And then you have to plan out what a project looks like. So I feel like that's a missing piece because that's brought to you when you're in school, right? You have the problem and they say, here's the table, here's all the data. So that's missing in the school part. So of course, it's gonna kind of be forgotten a little bit. So definitely that piece. And then for myself, I'm not going to say how long ago it was, but that was a long time ago that I was joining things. But for myself, I think it was about the communication around myself. And maybe I don't know a model to try, or I don't know the best model. So I should just go ask like another person on my team or an external team, or I should just research and see who should I ask, you know? So I think that's the big part that was missing for me.
Gotcha. Yeah, that actually plays really into well, like my next question. You kind of touched on this already, but um, as someone like me who I don't have a lot of statistical experience, I'm just getting started in school and getting used to things, and it can be hard to know when to use something more complicated like a neural net or a more robust model. But how do you like decide when you should use something like that versus something simpler statistic method, like a linear regression, for example. Because I know that can be hard for me to see when to use things in practice. Is that something that just comes with experience? And, how do you make those calls now within your day to day?
Yeah, so I work at Oracle, which is more about, the business and the revenue, everything like that. So it's kind of a disappointing answer, I would say. You really, if you want to do like the really fun neural net modeling, you have to have a really good excuse. But because it's going to take a little bit longer, it's going to be a little bit more expensive, probably. So a lot of times, you're going to say, okay, I can do this simple model, the linear regression, which gives you, an AUC of zero point 0.6, or I can do a neural net, and that gives you zero point 0.9 AUC. So you give those options to leadership, and then a lot of times leadership will say, this is the cheaper one that's faster, so I want you to do the linear regression.
Yeah, and kind of going, that makes a lot of sense, especially in, navigating that business relationship between, the technical side and, keeping costs down. So, moving off that, I know that you regularly communicate findings across engineers, product teams, executive leadership. So does effective leadership and communication look like for a data scientist when the audience has very different levels of technical understanding?
Yeah, so this is a really important skill to go in as a data scientist to know. You really have to be able to pretend that you're whatever audience you're presenting to. So the first time you present to an audience, it's going to be really hard because you don't know the questions. You're trying to guess what questions they're going to ask. But then the more you present to them, you'll get better. Um, in my experience, what I found that is that data scientists, they want to know, what models did you use? How did you tune these models? Like, What do they look like? What did you compare? They want to know all that. And then executives, you want to use as few words as possible. I don't care if it's dashboards, presentations, no, as few words as possible. So you want to start off with like, this is what we found. Like, no models that you use, no mat, nothing. You put all that in an appendix because, of course, there's going to be that one executive that has those questions. But yeah, executive level. It's going to be tell us the big picture. We want to think about revenue and how this affects revenue, right? Whereas the data scientists are going to be more like, oh, we want to hear about the cool things. So, yeah, different audiences require different answers to different questions.
Right, that makes a lot of sense. I appreciate that perspective and kind of thinking about communicating with executives and these different levels of leadership. And as I move forward, I kind of want to blend that data sciencey side with the business side of things. So that's something that I'm really trying to build my skills on early, so that I can kind of bridge the gap between those technical and non-technical leadership positions. So. Just kind of moving on to just, I know that you've worked a lot with big data at Oracle, and other places. It's a lot of big, messy data. And, as a student, a lot of times I'm given a data set that's really nice. It's not too large. There's not a lot of problems and holes in it. So just kind of in your experience, what does good data actually mean in practice and, working at a scale that you're working at Oracle?
Right. So it's pretty difficult and it's way different when you're talking about a large scale. So you have to think of things, there's a subjective approach and then objective approach as well. For objective things, you have to look at general I have this huge data set. And then you look at the data generally and you put together what is the story telling you in that data set. So you can look at in each column, what values am I seeing? And does that make sense? And for example, I'm not going to use like the exact words or anything just to protect, clients and stuff, but we did get data from a client where one of their columns was something like this household has a glass of wine each week. So you would expect yes or no. And then one of the answers was pool. And so that, isn't clean data because when data is being transferred, there's always a chance that it ends up messy somewhere. So you have to look at it objectively like this. Is this everything we expect to see? We expected a number here, but instead it's a character. Things like that. Then you can also look at things subjectively and logically. We had another client who they gave us data where 50% of their people were high level, but then 50% of their people were at the bottom of the income bracket. So that didn't quite make sense to us. So, we asked them, how do you clean your data? Like, can you make sure that people are filling this out truthfully and everything? We didn't end up going with that client, but yeah, you just have to logically look at data. Does it make sense? And even if everyone was telling the truth for their data, do we really want that data, like what that story is saying?
Right, right. And I think that's a really powerful difference that you said there between the subjective and objective. I think that's a really cool insight that I'll definitely reflect on, kind of balancing those two things because I know as I progress through college and get into my career, I know messy data will become more and more a part of, my experience. So I really appreciate that. So kind of moving off of that, kind of the infrastructure side. So I know that you were involved in a migration that ended up saving the company a significant amount of money. So my question is, how much should data scientists think about infrastructure and costs, and how do you balance building good technical solutions with real business constraints?
Yeah, so this kind of goes back to the answer about how do you know what model to use. You should always, in the back of your mind, be thinking of the money and how much this is costing the company, revenue, everything like that, because that is what the leadership notices. And so, yeah, if you ever come up with a project where you're like, oh, I could save the company time, which time is money. I can save the company time, so you can always convert it to that money, and then you can go to leadership and say, I saved you this much by doing this change. Like that always, they love that. And so that always puts you on their good list. And even I've had some projects I really wanted to do because they were really fun. And so, in order to sell them to leadership, it's always a good idea to say, this is how it saves them money. And then they'll support your project and give you time and space to complete it, which is always valuable.
Right. That makes a lot of sense. Well, just kind of moving off of those questions, as we wrap up, wanted to ask you, you've worked across operations, statistics, data science, a lot of different cool projects, I'm sure. So what part of data work still excites you the most today?
So today I get excited by the um, statistical proof that I can bring to questions. Like the other day, I did get asked a question by my leadership, and they said, you can just eyeball it, just look at the data and tell me. And I said, no, it's going to take me about the same amount of time to do a chi-squared test and tell you like using p-value and stuff. So that's what I'm going to do. So that was really exciting for me. And then programming also whenever there's a process that is maybe not as efficient or isn't giving us exactly what we want, whenever there's duplication or a way to rewrite things, put it in a modular form, change it up. I really get excited about that as well. Like, how can we improve this so it's super easy for any programmer to read and to edit, and for us to add things to? So I get excited about that as well.
Yeah, that sounds like a lot of fun.
Yeah.
So, kind of moving on, just finally, uh, some general advice. You've given me a lot of great insights today, a lot of stuff I can reflect on, and I really appreciate that. But if you could just kind of distill that down. So, if you were in my shoes, 19 years old, studying economics and statistics, still pretty young, still trying to figure out what direction to take, what general advice would you give me?
Sure. So, a couple of things. The first thing is I do want to address the AI because a lot of people in our field right now are talking about that. I will say that right now I work with AI every day, and it's not as much of a danger to us as people are making it out to be, which is good news for us. Right now, it is. A search engine, I feel like more. But if I were in your shoes and just coming into the field, what I would do is learn how to use AI as a tool to
Mhm.
help me in my job. How can you just use it to make your work faster? Like it can't do your work for you, but how can I use it as a tool to make my work, yeah, faster and more efficient? So that's the first thing I would say. And then the second one, in terms of just what you want to do, I feel like it's it's a lot easier when I'm working with data that I'm passionate about. And when, I have a question myself and, how many households in the United States have a child? I wonder. And then I can dig into the data and then you can like rip apart everything and you answer that. So, as you're going on your journey and you're trying to think about who should I apply to, what should I really look at, what interests you? What do you like to do? So, yeah, that's where I would start with that.
Yeah, thank you so much. That's some really great advice. And thank you again for meeting with me today. I've gained a lot of good information. And as I, go back through the recording and reflect on everything, I'm sure I'll have a million new ideas and new things to think about. So I really appreciate it.
Sure thing. Yeah. And you can let me know if you have any other questions or anything as well.
All right. Thank you so much.
Thank you.